This is how to combine like terms. Master this or fail the math SAT. Combining like terms is essentially learning how variables interact with each other. And even though it's not rocket science, pretty much all of the math SAT uses variables. So if you don't know how they interact with each other, you're guaranteed to fail about 70% of the math SAT. Which is why I did every single combining like terms problem in the digital SAT to help you master this concept with 3 simple chapters. Let's go into chapter 1. You're not dumb, you just need to use common sense. You'll see what I mean with this story. So imagine you're going into a grocery store. You're on the phone with your friend, y'all are chatting it up, and you go to the fruit section and you grab a banana. Then another one, and then an apple. If your friend asks you what you got, what would you tell him? Well, you're probably going to tell him that you grabbed 3 bananas and an apple. But notice what you just did. You went from banana plus banana plus banana plus apple to 3 bananas and an apple. You grouped the terms that were alike, the bananas, and you kept the others that were not alike separate. The apple. Now say you grab the kiwi. A banana, then a kiwi, then a mango, then a banana, then another 2 kiwis. What would you say to your friend? Well, you'd say that you got 3 bananas, 4 kiwis, and a mango. You combined the like terms, specifically from addition into multiplication, and now you left the other terms that were not alike separate. Also, you made the 2 kiwis at the end count as double since you grabbed 2 kiwis at the same time, and then another kiwi, that's 3 kiwis. Okay, chapter 2, words into algebra. So zooming out, what did we do in algebra terms? Well, we looked at the entire example and looked for repeated operations to the same term. In this case, repeated addition, and combined it into multiplication. But that begs the question, can we do the same with repeated multiplication? Can we group it? And what would we group it to? Well, the answer is with repeated multiplication, we group it into exponents. In fact, we can formalize this too. When we multiply repeatedly to the same term, the number of total multiplications can be grouped into the exponent. Let's use these examples to elaborate here. X times y times x times z times x times x. First, we have to realize we're multiplying multiple times, right? So that implies that we're going to group it into an exponent. First, we have to see that the x is multiplied by itself 4 times, so we group it appropriately, turning that 4 amounts of repetitions into its exponent. Nothing else is combined because nothing else is repeated, leaving us with y times z times x to the 4th. Example 2. Z plus 2x plus y plus x plus z. Just as before, we realize that we're adding repeatedly, which implies grouping like terms using multiplication. We see that the z's are being added twice, so we group that. And that the y is added once, so we separate that. Finally, we see that the x has 2 terms for the x, right? This one and this one. For 2x, we realize that it's just x plus x. And then adding the other addition, then we're left with 3x, leaving us finally with 3x plus 2z plus y. And here's this monster of a problem. With these skills, you should be able to solve it. I'll just leave this exercise for y'all. Chapter 3, abstraction. How to solve every single problem using this concept. So, in simple terms, abstraction means just focusing on the important ideas and ignoring the rest. So how can we use this to solve the hardest and weirdest problems? Well, the key ideas here are that so long as the terms are being repeated, no matter how weird that term is, under some type of operation, no matter how weird that is either, we can group it. So for example, apple plus banana plus banana plus banana is equal to apple plus 3 banana. In the same way that xy plus 3 minus x plus 3 minus x plus 3 minus x is equal to xy plus 3 times 3 minus x. We grouped addition, no matter what that object is, into multiplication, depending on the amount of times that we repeat it. So in general, we can have something like A times anything plus B times anything plus C times anything grouped into A plus B plus C times anything. And this happens the same with multiplication. So let's say 4 times 3 times 3 squared times 4. That would be grouped. Well, you have 2 repetitions of that 4 multiplication. You have 3 repetitions of that 3 multiplication, right? So it would be turned into 4 squared times 3 squared, 3 to the third. In the same way, we can apply this logic with just the weirdest object. Let's do xy times z squared times xy. Well, we have 2 xy's, so xy squared, and we have 3 z's, so z to the third. In general, that same idea can be generalized to anything to the a times anything to the b times anything to the c into anything to the a plus b plus c, time, like whatever, right? When you're combining, the terms don't matter. You can replace the xy's with boxes, a unicorn, or anything really, and all the rules apply the exact same. So just focus on what matters: the amount of repetitions and the operation that you're doing. To make this point even more clear, let's use 2 hard examples. 3 times x squared minus 9 plus 3 minus x times x squared minus 9. So let's start with the basics. What's being repeated? Well, the object that's being repeated is x squared minus 9. And we're adding it, right? That's our operation. So we should turn it into multiplication. Now, the next question is, how many repetitions do we have? Well, in this case, we have 3 repetitions at the start of that object, x squared minus 9, and then we have 3 minus x repetitions of the x squared minus 9. So the total amount of repetitions would be 3 plus 3 minus x, leaving us with 6 minus x grouped, so multiplied, to x squared minus 9. And let's, just for the sake of it, look at this other example. This one looks awful, but let's ask ourselves the same questions. What's being repeated? What's our object, right? And what's our operation? Well, what's being repeated is this monster, right? That, like, x squared to the y e to the whatever. That's being repeated, right? So, and it's multiplied, right? So how many times is it being multiplied? Well, it's the total number of multiplications, which is the addition of our exponents. So y minus 5 plus y plus 3 plus x, leaving us with this monster, right? To the 2y plus x minus 2. It's that simple. And you got it.